Now that we know how to solve systems of linear equations, we will solve applications that are modeled by systems of linear equations. Let's, though, go through our problem-solving steps that we can use when solving an application. Step 1, understand the problem. During this step, become comfortable with the problem. Some ways of doing this are to read and reread the problem, choose two variables to represent the two unknowns. This is a little bit different than before. Choose two variables to represent the two unknowns, construct a drawing if possible, propose a solution and check. Pay careful attention to how you check your proposed solution. This will help when writing equations to model the problem. Step 2, translate the problem into two equations. Step 3, solve the system of equations. And step 4, interpret the results, check the proposed solution in the stated problem, and state your conclusion. We still have basically 4 steps: understand, translate, solve, interpret. But now we're dealing with systems of equations. So let's look at our first application. Two numbers total 83 and have a difference of 17. Find the two numbers. So as we understand this problem, notice that we are looking for two unknowns. We are looking for two numbers. So I let x be one number and y be the other number. Then we will set up two equations forming our system of equations. We're told these two numbers have a sum of 83, and we can use that to set up one equation. That means that this number, x, plus the other number, y, is equal to 83. And then we're also told that the two numbers have a difference of 17. Since they have a difference of 17, we subtract. X minus y is equal to 17. I've translated to a system of equations. Now let's solve this system. I believe I'll use the addition method. Remember, you have the addition method and the substitution method. I'll use the addition method because if I simply add these two equations, the y's subtract out. So x plus x is 2x, and that equals 83 plus 17. Let's see, that is 100. And then to solve for x, on the left side and on the right side, I'll divide by the coefficient of x, which is 2, so x is 50. So it appears that one number is 50. Now just think about a system of equations for one moment. If you have one number in the solution, how do you find the other number, the corresponding, in this case, y value? You choose an equation in the system, substitute 50 for x, and find y. You do the same thing here. I'll just choose this first equation. X plus y is 83. I'll let x be 50. Plus y is 83. So y is 83 minus 50, which is 33. So y is 33. So interpret, check. Now how can you check? Find the sum of these two numbers, make sure the sum is 83. Find the difference of the two numbers, make sure the difference is 17. It will be. So to interpret, then we'll also state our results, and our results are that the two numbers are 50 and 33. There we go. Let's now try another application. Anne-Marie Jones has been pricing Amtrak train fares for a group trip to New York. 3 adults and 4 children must pay $159. 2 adults and 3 children must pay $112. Find the price of an adult's ticket and find the price of a child's ticket. All right, if you need to reread the problem, Notice we're looking for the price of an adult ticket and the price of a child's ticket. So if you'd like, you can use X and Y. In this case, I'm just using A and C to give meaning to this. I'm using the variable A to stand for the price of an adult's ticket and the variable C to stand for the price of a child's ticket. Notice we were told that the price of 3 adult tickets plus 4 children's tickets is $159. How can we translate that information to an equation? Well, what is the price of 3 adult tickets? If an adult ticket costs A, the price of 3 adult tickets is 3A. And the price of 4 children tickets costs 4C. And that is $159, that total price. Remember, we are also told that the price of 2 adult tickets plus 3 children's tickets is $112. So let's translate that to an equation. 2 adult tickets, that price is 2 times A, plus 3 children's tickets, that price is 3 times C, or 3C, and that is $112. Now that is my system of equations. You need to solve this system of equations for A and for C. So for the moment, forget that it's an application and solve this system. I'll talk about it a moment and I'll let you solve. If you want to eliminate the variable A by making these coefficients opposites, you can multiply the top equation by, say, -2 and make this coefficient -6, and the bottom equation by 3 and make this coefficient 6. Now make sure you multiply the entire equation through by -2 and the entire equation through by 3. If you want to eliminate the C's, you can multiply the top equation by -3 to make it -12C, and the bottom equation by 4 to make it 12C. It's really up to you. That's just a few options. I'll let you solve, though. If you solve, you'll have that C is 18 and A is 29. Now, what does that mean in the context of this problem? That the price of a child's ticket is $18 and the price of an adult's ticket is $29. Now, how can you check? See if the money needed for 3 adult tickets and 4 children's tickets is $159, and then see if the price for 2 adult tickets plus 3 children's tickets is $112. It will be. Let's now try another application. The Santa Fe National Historic Trail is approximately 1,200 miles between Old Franklin, Missouri and Santa Fe, New Mexico. Suppose that a group of hikers start from each town and walk the trail toward each other. They meet after a total hiking time of 240 hours. If one group travels 1/2 mile per hour slower than the other group, find the rate of each group. First of all, once again, this is a distance, rate, and time word problem or application, except that we will be allowing ourselves to have 2 variables. Well, we're looking for the rate of each group, so why don't we let X be the rate of one group and let Y be the rate of the other group. Now, were we told anything about time? The answer is yes. We were told that each group travels 240 hours hiking time. So the time of this group is 240, and that's in hours. The time of this group is 240. Once again, that is in hours. Now let's complete our chart by using the fact that rate times time is distance. So in this row, rate times time is distance. We can represent this distance by 240 times x, or 240x. We can represent this distance by y times 240, or 240y. Now, were we told anything else about distance? The answer is yes. We were told the total length of that trail is 1,200 miles. Since we were told that that's the total length of the trail, isn't that the distance one group travels plus the distance the other group travels? And the answer is yes. So the distance one group travels, 240x, plus the distance the other group travels, 240y, is equal to 1,200. Now, if you're asking yourself, well, don't we know that each group travels the same amount of distance? The answer is no, because we are told that the rates are different. We are told that one group travels a half mile per hour slower than the other group. So we know the distances, in fact, aren't the same, but that they must total, or they should total 1,200. Now, we've got two variables and simply one equation. We do need another equation to form our system. Now, we were told that one group travels 1/2 mile per hour slower than the other group. How will we use that to set up a second equation? Be very, very careful. One group travels 1/2 mile per hour slower than the other group. So let's suppose this group is the slower group, the group traveling at a rate of x miles per hour. If that is the slower group, isn't this number smaller than this one? Since this number is smaller, don't I take the slower group, add to it the 1/2 mile per hour to equal the faster group? And yes, the answer is yes. If we take the slower group, add the 1/2 mile per hour difference between the two, we will get the faster group. So here is our system of equations. Now, I'll let you solve this system of equations. You can either use the addition method or the substitution method. Since this is solved for y, you may just want to substitute this for y in the first equation and then go through and solve. Once you solve then, and you will be solving then for x because you'll have an equation in nothing but x's, you'll have then that x is equal to 2 1/4, and that's miles per hour. Once you solve, you'll have x equals 2.25 or 2 1/4 miles per hour. How do you find the other group? The other group, take this rate, add 1/2 to it, and you'll have 2 3/4 miles per hour. Let me write that better. I'm thinking of it in a decimal, 2.75, but in a fraction, it's 2 3/4 miles per hour. And then I'll let you check by going to the original stated problem, check these two rates and make sure you're okay. One rate is 2 1/4 mile per hour. The other rate is 2 3/4 miles per hour. Dorn Schmidt is a chemist with Gimco Pharmaceutical. She needs to prepare 12 liters of a 9% hydrochloric acid solution. Find the amount of a 4% solution and the amount of a 12% solution she should mix to get this solution. Now remember, we are mixing a 4% solution rate, concentration rate of hydrochloric acid solution with a 12% rate to get a 9% rate. And we want to know how much of each of these in order to get 12 liters. So if I multiply the rate times the liters of the solution, I'll have the actual liters of pure acid. In this column, then, I place 4/100ths times x, or 4/100ths x. Here, 12/100ths times y, or 12/100ths y. And here, 9/100ths times 12. Now, how can we translate to two equations in two unknowns? We do know that the liters of this solution plus the liters of this solution should equal 12. We want 12 liters. So it is true that x plus y equals 12. And then also the liters of pure acid here plus the liters of pure acid here must equal the liters of pure acid in the solution we want to obtain. So this amount, 4/100 x, plus this amount, 12/100 y, equals this amount, 9/100 times 12. And here is your system of equations. It's up to you how to solve. You can use the addition method or the substitution method. If you want to use the substitution method, you may want to solve this equation for x or y, then substitute in the other equation. Whichever way you choose to solve, you will have that x is equal to 4 5/10 or 4 1/2. And remember, it is liters, and y is equal to 7 1/2 or 7 5/10 liters. Don't forget y, that is the 12%, and x, that is of the 4%. So you solve that system, and there is the solution to our application. Let's look at one final application. Recall that two angles are complementary if the sum of their measures is 90 degrees. Find the measures of two complementary angles if one angle is twice the other. So we have a diagram. Supposedly these are two complementary angles. We have one measuring x degrees, one measuring y degrees. If they are complementary, then their sum is 90 degrees. So I do know that x plus y is equal to 90. I've translated to one equation. What can we use to translate to another equation? Remember, we're given that one angle is twice the measure of the other angle. So it makes no difference which one you choose, but choose one. I'll say that y, the measure of y, is twice the measure of x. Now, if you let x be twice the measure of y, you'll still be okay once you solve, because we were not told specifically which one is which. Here is our system. Solve this system for x and y. By the way, if you'd like, you can just use directly the substitution method. For y in this equation, you can let y be 2x, go through, solve for x, and then solve for y. If you solve for x, you'll have 30, which will stand for 30 degrees, and then y is 2 times x. 2 times 30 degrees is 60 degrees. Let me go ahead and write that down for y then. Y is 60 degrees. And you can check, these are complementary, their sum is 90 degrees, and this angle is twice this angle. At this time, practice solving applications that are modeled by systems of equations. The Planning Department of Abstract Office Supplies has been asked to determine whether the company should introduce a new computer desk next year. The department estimates that $6,000 of new manufacturing equipment will need to be purchased, and that the cost of constructing each desk will be $200. The department also estimates that the revenue from each desk will be $450. Now this has to do with revenue, cost, and we'd like to figure out the break-even point. When does the company start making money? So I've written down a few facts from the application. $6,000 is a one-time purchase of new equipment, and then an ongoing cost is $200 per desk to construct the desks. Then they figure they can bring in $450 of revenue per desk. What I'd like to do first is come up with the revenue function. Now I'm letting X be the number of desks, computer desks. So let's write down the revenue function and I'll call it R of X. If we are making $450 or bringing in $450 per desk, the revenue function is simply 450X. Now let's come up with the cost function. I'll call it C of X. Think about the cost now to the company. The cost, of course, is that one-time cost of $6,000. That's a one-time cost, plus this much per desk. So since it's this much per desk, it's plus 200X. Now, of course, you can write this cost function as 200X plus 6,000. It makes no difference the order here because addition is commutative. Now, how do you find the break-even point in any endeavor? Once you have revenue and cost, you set revenue equal to cost, and then you solve for your variable, in this case, X. So we'll set revenue, 450X, equal to cost, 6,000 plus 200X, and we solve for X, the number of desks. How do we solve this equation for X? We'll subtract 200 from both sides. 450 minus 200 is 250X is equal to 6,000, and then you solve for X by dividing both sides by 250, the left side by 250, the right side by 250. If you do so, you'll find that X is 24. Now, what does that mean? That means the company will break even at 24 computer desks. So there is the break-even point for the company. If you'd like, you can certainly figure out the revenue and certainly figure out the cost. I'll let you do that if you want to check. But at 24 desks, the revenue should equal the cost. Now let's look at another application. The measure of the largest angle of a triangle is 80 degrees more than the measure of the smallest angle, and the measure of the remaining angle is 10 degrees more than the measure of the smallest angle. Find the measure of each angle. Make sure you read and reread until you understand, and I would suggest, since we're talking about a triangle, that you draw a diagram. So here I have a triangle. I'm letting Z be the degree measure of one angle, Y be the degree measure of one, and X be the degree measure of one. As a matter of fact, it looks like Y is the degree measure of the greatest angle, X is the measure of the smallest angle, and then Z is the remaining angle. So let's see how we can set up a system of equations. Remember your application. We are told that the measure of the greatest angle, or the largest angle, it is in our case Y, it is 80 degrees more than the measure of the smallest angle. So it is 80 degrees more than X. Y is X plus 80. And then remember our application said the remaining angle, which must be that one measuring Z degrees, is the measure of the smallest degree plus 10. The measure of the angle with the smallest measure plus 10. So Z is X degrees plus 10. Now, we have three unknowns here, X, Y, and Z. So we need three equations. Can you think of something we've not used yet that we can use to write another equation? Well, we do know the degree measure of a triangle, that sum of the degrees is what? 180. So that leads us to x degrees plus y degrees plus z degrees is 180. And here we have a system of 3 equations in 3 unknowns. Now, how would you like to solve this system? It's really up to you. Notice we do have this equation solved for y, this equation solved for z. Why don't we use the substitution method? Why don't we substitute, and not only is this solved for y and this solved for z, but in terms of x only. Do you see that if I substitute for y, x plus 80, and if I substitute for z, x plus 10, I'll have a single equation in a single unknown x. So let's do so. I'm going to rewrite this equation, x plus, instead of y, I'll write x plus 80. Plus, instead of z, I'll write x plus 10. And that equals 180. Of course, you can use the substitution method. You can use other methods, but it is a good idea to sit there and study your system for a moment before deciding how to proceed. Now, let's go ahead and solve this equation. I have 1x plus 1x plus 1x, that's 3x, plus 80 plus 10, that's 90, is equal to 180, and that is then 3x is 180 minus 90, which is 90. Divide both sides by 3, and I have x is 30. Now for a moment, let's think of this as a system. The solution of this system of 3 equations in 3 unknowns is an ordered triple of numbers, and we know the x value is 30. How do we find the y value or the z value? Well, study this system for a moment. Now that we know x is 30, study your system. Just so happens that knowing that x is 30, y is 30 plus 80 then, so y is 110. And notice you can either plug in 30 for x, 110 for y here, and you'll find z, but notice z is x plus 10, so z is 30 plus 10 or 40. So we have that this degree measure is 30 degrees, this is 110 degrees, and this is, and by the way, what am I doing right now? I am interpreting this solution, and this is 40 degrees. How can you check? You can check by finding the sum of these 3 numbers. It should be 180, and it is. Seeing that this is 80 more than this, and this is 10 more than this, it is. So we are correct, and we have found our solution. At this time, practice modeling applications with systems of linear equations.